Hi, I'm going to show you how to run a notebook on Denali or Tallgrass. And this little demo is assuming that you've already followed these instructions for getting started with HiTest on on-prem HPC that you can find on GitLab in the water emission area HiTest area. So what I do is once this is all set up, I can bring up a terminal here on my Windows machine, and I can SSH to Denali. Of course, I have to be on the trusted internet connection, the TIC, so DOI-net, so I'm on Pulse Secure. So I just logged in. I can start an interactive session of a certain number of hours by, I usually type like start 12 for a 12-hour session. And I can see by the prompt that changed that I'm on a different node. And then I can just start my Jupyter session by typing start Jupyter. So I always start my Jupyter session after I've gotten off of the main node onto a compute node. So when I type that, I get back a little step 1, step 2, step 3 middle message here. And the step 2 is to copy this SSH command. So I'm going to do that. I'm going to do a control insert here on my Windows machine to capture that SSH command. And then I wait until I see that the notebook is completely started. So when I get down, when you see use Control-C to stop the server, that means your server is running. So I can open up another window now and drop that URL, that SSH tunneling command in. And when I hit return on that, I'm logged in. And that means that I can go to step 3 here, which if we scroll up is to browse to HTTPS localhost 8889. So, oops, no, I don't want to do that. Sorry. Resuming operation. So I go to a browser tab and I type in localhost 8889. And if it's the first time, I'm going to get prompted for a password. But if it's not the first time, I'm not going to have to put in my password, and I just immediately go to JupyterLab. So this says localhost 8889, but I'm actually on Denali here. And so now I can start running things close to the data. So I'm going to clone a notebook. So I'm going to go plus, and I'm going to scroll down here on the launcher and select the terminal. So now I've got a terminal, and you can see that I'm on Denali. I guess, what is that host name? Yeah, that's not, okay, that's my node. Anyway, there's, I'm sure there's something that tells us we're on Denali. Yeah, anyway, so there's Slurm cluster name tells us that we're on Denali, among other things. So, so let's go ahead and clone this repo. So that has a few notebooks in it. So this is the HiTest development repo. We can go over here to the clone button and copy that. Go back to our terminal, and I'm going to cd to my, got a directory called repos, and I'm going to git clone that repo. So now over here in this file browser, here's my repos directory. I can go in there, and I've got this thing called development that we just downloaded. I can go into gallery and select one of these notebooks. I'm going to select this CONUS 404 Explorer notebook. And it comes up here unrendered. You could click here and look at the rendered version, but what we want to do is just go ahead and run this thing. So we could go up here to kernel and just do restart kernel and run all cells. I often do restart kernel and clear all outputs, just to make sure that if there's any output here before, it's nice to clear it out. And then once it's cleared out, you can go ahead and like hit shift enter to enter a cell, or you can go up here and click these little icons. But I prefer to just, if I'm just going to walk through a cell, I'm going to do shift enter and just repeat that for each cell to sort of walk through and explore things, and add new cells as necessary. One thing, so when you see this little star here, it means that it's waiting to compute that cell, and when that turns to a number, that will mean that that cell has been completed. And here we're just importing a bunch of packages that are used in the notebook. And the reason it's taking a while is because the Python packages are on a sort of a remotely mounted file system. And it takes a while to pull all those packages, up to a minute actually, to pull all that stuff in. You can see it turned to a number, so now we're good to go. And I'm not going to talk about what's really happening in this notebook. I'm just going to start executing cells, but you can see that, well, we're opening up an intake catalog. There's some different data sets that appear. We're loading this on-prem data set. Obviously, it wouldn't, well, we could load a cloud data set if we wanted to, but if we're on-prem, we might as well load an on-prem data set. And here we're looking at some snow data. We can select a particular time and load that data. So it only, if you type load, it'll actually force the loading of the data. Otherwise, it'll just basically do a lazy calculation and not pull any real data. So just to make sure that we've got something here, we can do on that data array, we can do da.hvplot and give it some quad mesh arguments using Holoviz, and this is just a way to quickly take a peek at a map to see if the data looks correct. And you can see that, yeah, it looks like CONUS 404. We could zoom into a particular, actually I like to turn this little hover tool off just so it doesn't annoy me, and we can zoom into a particular region and should get an updated map, and we can pan around and stuff like that. So it's pretty handy little viz tool here. We can also load a time series at a specific grid cell, do lots of other things, of course, but here we're finding the nearest IJ location to that lat long location, and then using that IJ to extract a particular value here from the temperature at 2 meters data. So we load another data array that's the temperature at 2 meters, and in this case, we're actually going to plot a time series at that location over time, just to show that we can pull a fair amount of data pretty quickly from this data set. And there's the entire 40-year time series. And again, we can zoom in here and see the full extent of the data, look at particular events if we want to by hovering over them, and so on. So then finally here we extract a subset of data to netcdf by giving it a bounding box, figuring out the IJ indices, and then going ahead and slicing out a particular time period. I'm just going to walk through this all the way to the end. So we're picking a particular region of the DRB, the Delaware River Basin, picking a few variables that we want to output, and then just writing that to a file. So hopefully that gives you some idea of how to run a notebook, some of the different things you can do. So that's it for the demo.